Does your ore transportation from mines have difficulty in verification of tonnage and trips? Is theft during transit causing hidden losses for your mining operations? Wouldn't you prefer an option that prevents ore theft, verifies transportation trips, catches fuel siphoning during transportation, and ensures driver authentication all in real time through a system that is easy, accurate, and economical? RFID, radio frequency identification device, makes it possible. With Essence xtenna-based RFID, you can uniquely identify and accurately track each vehicle from amongst a fleet of thousands transporting ore, and verify that the grips it makes and quantity it delivers are in order. This ID system lets you monitor the movement of trucks from mine to destination, as well as during transit. It is integrated with a database system that records quantities of ore sent and delivered, verifies trips to prevent overpayment, monitors fuel and driver compliance in real time, and automates reports. A radio tag is affixed on every truck transporting ore from the mine. Each RFID tag has a unique ID number that corresponds to the individual vehicle to which the tag has been affixed. Each tagged vehicle is located with xtenna devices that are mounted at weighbridges and verification booths at source and destination. Long-range data and video connectivity of 25 kilometers is provided through Essence ERF211E and ERF711E interlinkable radio masts that wirelessly link up the entire mining area. Xtennas are extended range RFID reader antennas that send and pick up signals from every tagged vehicle and transmit them to a central database. Resulting in instant identification and tracking in a way similar to a cell phone communicating with a signal tower. The system supports seamless integration and back-end connectivity with Oracle, DB2 and SQL and ERP such as SAP, enabling easy management of our transportation, optimum delivery scheduling, improved workflow, synchronization, and greater overall efficiency. RFID helps prevent theft of ore during transportation by automating the process of weighment verification at source and destination. Before a truck is loaded with ore, it is weighed at the mine to obtain its tare weight. The unloaded truck arrives at the weighbridge, and its RFID tag is detected by the xtenna mounted there. The system automatically logs in the tare weight of the vehicle. The unloaded truck moves within the mine to the area where ore excavation is taking place. The truck is then loaded with freshly excavated ore. The fully laden truck arrives at a weighbridge, and its RFID tag is detected by the xtenna mounted there. At the weighbridge, the gross weight of the truck is automatically logged in. The system generates the net weight of the ore being transported by deducting the gross weight from the tare weight of the vehicle. The truck carrying ore arrives at its unloading destination, which may be a crushing plant, a rail wagon, or a barge loading area. The truck goes to a weighbridge, where its gross weight is once again ascertained. The xtenna at the weighbridge reads the truck's RFID tag and logs in the gross weight. The system tallies the gross weight at departure with the gross weight at destination arrival. An alert is automatically issued if a significant discrepancy is found, indicating unaccounted loss during transit. When a truck loaded with ore leaves the mining area weighbridge, the system logs in the ore quantity, destination, and time of departure. This data is instantly available to the system at the truck's destination area. On arrival at the unloading area weighbridge, the system identifies the vehicle, matches dispatch data received from the mining area, logs in the ore quantity and time of arrival, and issues a delivery receipt to the truck driver. This delivery data is instantly available over the network to all other weighbridges in the unloading area. After obtaining the delivery receipt, the truck driver takes his vehicle to the spot where he will unload the ore from his truck into the waiting barge or rail wagon. If the driver, instead of unloading, takes his truck once again to another weighbridge, the xtenna at this weighbridge will identify the vehicle as having already logged in its trip completion. This automatically prevents issuance of multiple delivery receipts for the same trip and puts an end to misuse and driver overpayment. The truck driver takes his delivery receipts to the payment booth to collect payment for the trips he has made. An RFID-based system thus automatically ensures that delivery receipts match with trip records and correct trip reimbursement is made at all times. Essence RF-enabled equipment makes possible effective real-time monitoring of fuel consumption by individual vehicles in transit, as well as their fuel intake during fill-up. A fuel sensor is placed inside the truck's fuel tank. It communicates locally with Essence Strata, a GPS/GPRS tracking device that is fitted inside the vehicle. This device enables live tracking and mapping of the truck via satellite along its entire route. The fuel sensor continuously monitors change in the fuel level of the moving vehicle. A halted truck followed by a sudden and significant drop in fuel level when a truck restarts indicates that fuel has been siphoned off from the fuel tank. This is determined in real time, along with the exact GPS location of the truck. When fuel is filled up at the mine's fuel pump, the system records the transaction and the fuel dispensed by the filling station. The fuel level displayed when a truck restarts confirms the quantity of fuel filled up. If the fuel filled up displayed by the fuel sensor is less than the quantity dispensed by the fuel pump, it indicates that some fuel has been diverted during fill-up. This is determined in real time as soon as the truck is restarted at the filling station. Real-time monitoring of fuel consumption enables alerts for timely fuel replenishment for each truck. This ensures that mining transport operations are not delayed and workflow efficiency is maintained. A seat pressure sensor is fitted within the driver's seat of the truck. An iris scanner is mounted on the dashboard behind the steering wheel. These devices communicate locally with xtenna, a GPRS controller tracking device that is fitted inside the vehicle. Seat sensor data is continuously monitored by the tracking device along its entire route. The sensors of the seat pressure sensor automatically activate the iris scanner when a person sits on the driver's seat of the truck and attempts to turn on the ignition. The iris scanner telescopically zooms forward from the dashboard through the steering wheel up to the driver's face. It can only be accessed when the person is in a sitting position on the driver's seat. The driver's iris is scanned, and this data is sent by xtenna via satellite to the central database. The ignition gets turned on only after the driver's iris scan is authenticated and verification data received back by xtenna inside the truck. If the seat pressure sensor detects that the truck driver has got off his seat, the xtenna controller automatically deactivates the ignition of the vehicle. The activation sequence and driver verification has to be repeated each time the driver's seat has been vacated, even during the course of the trip. If the driver gets off his seat while the truck is moving, in order to let another person sit there, the seat pressure sensor detects this attempt, and the xtenna controller deactivates the ignition and brings the vehicle to a halt. When a non-designated person gets on the driver's seat, the iris verification will fail for the unauthorized driver and the truck's ignition will not restart. An alert is automatically sent to the supervisor when this happens. This prevents the truck driver from handing over the driver's seat to an unauthorized person after he has initially authenticated himself at the start of the trip. Xtenna maximizes the benefits of RFID in mining by uniquely enabling power supply and lossless digital data transmission over long distances through a single, inexpensive cable. It works seamlessly with asset tracking tags and can be easily integrated with existing enterprise software and IT systems. Xtenna's asset tracking saves time, improves monitoring, and reduces costs. Providing you enhanced efficiency, smooth operations, and higher returns on investment, helping your business take the next step forward.